Okay, so note 6, combining random variables. So it says let x and y be two independent random variables with the following probability distribution. So they give us the table x and the table y. They said if we let s equal to x plus y, create the probability distribution below. So what we're doing is we're creating a new table. Okay, so I'm going to go ahead and draw that table. And I have S and then the probability of S. Okay, so what we're doing here is we're going to add all of the X values to the Y values. So for example, we can do 1 plus 5, and then 1 plus 10, 2 plus 5, 2 plus 10, and then lastly 3 plus 5, and 3 plus 10. So that gives us 6, 7, 8, 11, 12, 13. And then in order to find the probabilities, what we're going to do is we are going to multiply the two probabilities from the numbers that we added together. So for example, since we did 1 plus 5, and that gave us 6, that means I'm going to do 0.3 times 0.4, and that's going to give me 0.12. So if I do the same thing for the entire table, I get 0.08, 0.2, 0.18, 0.12, and 0.3. So this is a new probability distribution where S is representing X plus Y, and the probability of S is representing the probability of X times the probability of Y. So now it says it wants us to find the following: all of the expected values and then all the standard deviations. So in order to do that, what we're going to do first is we're going to look how to do this on Desmos, okay? So for expected value, and I'm going to change my color here. Okay, so for expected value, you're going to create two lists. So we're going to have L1 equal to, and then L2 equal to. And then what we're putting in those brackets are going to be our random variable and then the probability of that random variable. Okay, and we can find those values from the table above. And then what we're going to do is we're going to say E is equal to the total of L1 times L2. So let's go ahead and do that, and we're going to use that table we just created for S. So this is going to be L1, and this is going to be L2, and that's going to help us find E of S. Okay, so that's going to be our first step. So I'm going to do list 1. Okay, equals, and then a bracket. And then I'm going to put in all of these S values. So 6, 7, 8, 11, 12, 13. Oops. Okay, then I'm going to go on the next one and create list 2. And then I'm going to put all the probabilities of S. So the 0.12, 0.08, etc. So 0.12, 0.08, 0.2, 0.18, 0.12, and then 0.3. Notice how in each of my lists I have 6 elements. That's how I know that I'm inputting all the given information, because in my table I had 6 S values and 6 probability of S values. So then on the next line I'm going to do E is equal to, and then I'm going to go write total, and then I'm going to put parentheses, and then I'm going to do L1 times L2. Okay, and that gives me 10.2. So that's what I'm going to write here, 10.2. Okay. So in order to do E of X and E of Y, I would do the same thing, but then now replace my L1 and L2 with the ones that match with the table. So for X, I would be putting 3 elements in each list, and then for Y, 2 elements in each list, and it would give me my E of X and E of Y, which is 2.2 and 8. Okay. Now let's look at how to put in the standard deviation. So I want us to recall what the formula is for standard deviation. And so this is the formula that you have on the formula chart. So we have that standard deviation is equal to the square root, let me zoom in real quick, of the summation of x sub I minus mu of x squared times p sub I. Okay, that is what is on the formula chart. For Desmos, this is how we're going to type it in. We're going to type in S is equal to the square root of the summation of n equals 1 and the function length of list 1. Okay, then we're going to do list 1 bracket n minus e squared list 2 bracket n. And we have to put it in this way because that's how Desmos able to read the formula versus how we wrote it in blue. That's how you're going to see it on the formula chart. And all we're doing is we're replacing L1 and L2 with what really is x sub I and p sub I, and e with mu of x. Okay, so if I type this in, so this is S equals, and then I have the square root, so SQRT, that gives you the square root. And then sum of 1, and then at the top, I'm going to write the function length. And I forgot a T, there we go, length, parentheses, L1. Okay, then I'm going to go, then I'm going to do parentheses, L1, bracket n. Okay. See if it needs me to, nope, okay. So then minus, I don't, there we go, minus e. And what it's going to do, it's going to pull from our expected value equation that we just created above. Okay, and then I want this to be, well, squared. Oh no, how do I get rid of that? There we go. Okay, then times L2 bracket n. Oh no, it didn't all go under that square root. Sorry, I'm not used to using Desmos on my iPad. So it's a little different just having to deal with this keyboard. Why can't it just go right here? Okay, let me try that again. Still not. Sorry, let me just do this again. Okay, now it looks like it's starting to go. Nope. There we go. Now it's following with me. That square root has to go over the entire thing. If it doesn't, you're not going to get an answer, and that's why no values was popping up as I was typing something in like they are now. Okay, so minus e squared, and then L2, and then bracket n. And so notice here I get 2.6. Okay. So I would go through that whole process, and notice once I have everything in my Desmos here, see if it will let me, no, it won't let me extend more. Once I have everything in my Desmos here, if I go ahead and start putting in list 1 and list 2 for x and y, it's going to automatically give me my expected value and standard deviation. So I would definitely try plugging that into Desmos to see if you get the same thing. But you should get 0.87 and 2.45 for those following standard deviations. Okay. So let's see. So for now, I'm just gonna close Desmos out, or just shrink it for that bit so I have majority of the space. So then it says there is a shortcut to find mean and standard deviation for the combination of random variables without having to create a new distribution. So notice up here, if we look at e of x and e of y, if we were to add those values together, they would give us e of s. Okay, so really what we just found is that e of x plus y is e of x plus e of y. Okay, same with e of x minus y. This is e of x minus e of y. For standard deviation, it's a little different. So the reason why it's different, it's not going to be simply being us adding or subtracting the standard deviations, but instead, standard deviation, which we're going to find out, is not impacted by adding or subtracting. So what that means is that the equations are going to be the same for both, and that is going to be the square root of sigma x squared plus sigma y squared. And this is going to be the same here. And so we can check this out. Okay, we can check this out by actually testing the problem we just did and plugging it into those equations. So we know that e of s is equal to e of x plus y, which is equal to e of x plus e of y. Well, e of s was 10.2, e of x was 2.2, and e of y was 8. So this gives us that 10.2 is equal to 10.2, which checks out. Then we can test the standard deviation. So the standard deviation of sigma x squared plus sigma y squared, okay, should give us sigma s squared. Or sorry, just sigma s, sorry. Okay. So if we plug in the values that we have, this is going to be the square root of 0.87 squared plus 2.45 squared is equal to 2.6. Well, if you put that into Desmos, that gives us 2.59988, which is equivalent to 2.6 if we round it. So yes, it checks out. Now we're going to look at linear transformations of random variables. So in this example, it says the head folks at Google decided to try a random salary assignment for their workers this year. They have the following probability distribution where x is equal to salary. It says, what is the expected salary for a Google employee and what would be the standard deviation? So in order to find e of x and sigma of x, we're going to go back to Desmos and we are going to use that table above and replace our list 1 and list 2 with those values. Okay. So I'm going to replace the values in this list with 50,000, 1, 2, 3, and then 60,000, 70,000, and 80,000. Okay, then I'm going to replace the list 2 with all the probabilities. So this is 0.2, 0.3, 0.4, and 0.1. And notice that it gives me the expected value is $64,000 and that the standard deviation is 9,165.15 cents. So $9,165.15. Okay. Then it says Google decides to give everyone a $500 bonus, create a new probability distribution, find the expected value and standard deviation, and see if anything changes. So here we're going to create a new table. And this is going to be X plus 500. We're giving everybody $500. Okay, so that's going to be 5,500, 60,500, 70,500, and 80,500. And the probabilities are not changing since we're giving everybody $500. Okay. So that means what we're going to do is we're going to replace our list 1 and list 2 stays the same. So I'm just going to go through here and replace all of this. So 50,500, 60,500, 70,500, and 80,500. Okay. So notice that the expected value of X plus 500 is equal to 64,500, which means 500 just got added to the expected value. And then notice that the standard deviation of X plus 500 is equal to 9,165.15, which means that the expected value increased by 500, but the standard deviation did not change. So now it's saying Google decides that it will pay cash at the end of the year for this salary. They will give out $100 bills. Let X equal the number of $100 bills they will give out. Create a new probability distribution and find the expected value and the standard deviation. Okay, so here's my table. So now this is X plus 500 over 100. And the probability of X plus 500 over 100. Okay, so that means I have 505, 605, 705, and 805, and all of my probabilities stayed the same. So I'm going to go back over to Desmos and again change my list 1. Oops. Okay, and so then I see that my expected value is now equal to 645, and my standard deviation is equal to 91.65. So it looks like my expected value, they divided the 64,500 by 100 and got 645. And standard deviation didn't stay the same this time. It actually decreased by dividing by 100 as well. So what this tells us is it tells us that expected value or mean is impacted by addition, subtraction, multiplication, and division, where standard deviation is only impacted by multiplication and division. So if we were to look at this below, this is the same as saying E of A plus E of B x. A and B are constant values, so this is the same as saying A plus B of E of X, which means that, again, this is affected in the same way. So the random variable affects the mean in the same way. So which means it's affected by addition, subtraction, multiplication, and division. Okay, versus standard deviation. So standard deviation of A plus BX is going to be the standard deviation of A plus the standard deviation of BX. Standard deviation of A doesn't make sense. We can't find the standard deviation from something that's not even there. So that's just 0, right? If we are given only one value A, how are we able to find where it varies? So we'll just say this is 0, okay? Then we can take the B out, just like we did an expected value, and this becomes B sigma X, but the only difference is that this has to be the absolute value. And the reason for that is that standard deviation is affected by multiplication or division to the random variable, but we have to remember that standard deviation cannot be negative, and that is because if you think of the formula of standard deviation, remember standard deviation is equal to the square root. Under the square root, we can't look at a negative number, which means standard deviation cannot be negative, so that's why we do the absolute value of sigma S. Okay. So now let's look at this example. It says, depending on the attendance of a minor league baseball team, the number of hot dogs and sodas sold at a game is given by the following table. So we have two tables here, one with hot dogs, one with sodas. So what we need to do is, on Desmos, just like before, we need to find the expected value of hot dogs and soda and the standard deviation of hot dogs and soda. Okay, so I'm going to have you guys try that on your own with your Desmos. Okay, and what I'm going to do is I'm just going to write out what you should have got. So E of H is equal to 1025. Sigma of H is equal to 793. E of S is equal to 680. And sigma of S is equal to 476. So then it says if the profit on a hot dog is $1.50 and the profit on a soda is 75 cents, find the average profit and then what is the standard deviation of that profit. So we're going to find two things. We're finding the expected value of profit and the standard deviation of profit. So the average profit is equal to the expected value of 1.5H plus 0.75S. Okay, which is the same as saying 1.5 expected value of H plus 0.75 expected value of S. So we plug in the expected values for hot dogs and soda, and we get 1.5 times 1025 plus 0.75 times 680. And plugging that in, that gives us $2,047.50 average profit. And then for standard deviation of profit, we would say that standard deviation is equal to the square root of 1.5 sigma H squared plus 0.75 sigma S squared, which is equal to the square root of 1.5 times 793 squared plus 0.75 times 476 squared, and that gives us $1,241.92. So what this is saying is on average they typically profit about $2,000 every game. Okay, that can vary by $1,200 in both directions. So they could end up making $1,200 more or $1,200 less. Okay. And then the last example here says, suppose two Pro Bowlers, Larry L. and Sam S., have the following distribution of scores. So here they give us the mean and standard deviation for each one, and we don't have to calculate it. Then it wants us to find the following. So we know that this is the same as saying E of L plus E of S, which is the same as saying mu of L plus mu of S, because expected value and mu both are mean. So then we can plug in those values. Mu of L is 239 plus mu of S is 244, and that gives us 483. Okay, then we can look at the next one, and that's mu of S minus mu of L, which is equal to 244 minus 239, which equals 5. Okay, I'm going to skip C and E for now. Okay, this is the same as saying 3 times 10, because that's the standard deviation of L, which is 30. And then this one here is the same as saying E of 4 plus 3E of L, which is equal to 4 plus 3 times 239, which gives us 721. And then the reason why I saved these ones for last is that we are going to be using the same formula for both. Because remember, no matter if we're adding or subtracting those random variables, it's always going to be the square root of sigma L squared plus sigma S squared. And so that is equal to the square root of 10 squared plus 25 squared, which is equal to 26.93. And that is our answer for both C and E.